Good day. You're welcome again to Mesolation Mathematics Institute, the home of the transformation of the abstract nature of mathematics into concrete concept. In this short video, we will be looking into what we call the algebraic process in such a way that we'll be analyzing each of some things we need to do. We have the algebraic process, algebraic processes. We'll be talking about the terms, expression, and equation. But in this short video, we will lay emphasis on the term. We'll be looking into the definition of a term. The second thing we are trying as much as possible to look into will be the abstract nature of the term with its analysis. And the third thing we'll be looking into is the concrete and environmental example of terms. And the fourth thing we'll be looking into is the relationship and the examples related to the abstract nature, so that we're bringing it to the simplification through the concrete aspect. Now, when we talk about the definition, we're talking about the definition of term. This is different from the school runs where we have the first term, second term, third term. But in the mathematical concept, a term is a unit entity or combination of entities combination of like entities. When we are talking about a unit entity, it's just as if you are talking about a noun. It's a particular thing, particular object, a particular place. Anything object is called a unit object. On the normal sense, unit entity. Let's say you have your house, your phone. Let's assume those are the unit entities, and we are talking about like entities. Houses, phones, cars. From this use of English, we can call this a singular. Singular. This is plural. That is the English like. When we are talking about the abstract nature of this, we are talking about our unit abstract. Let's talk about the abstract nature. We have indirectly talked about the concrete nature. This is the abstract nature now. When we are talking about unit entity, you can have numbers and variables. We have said in one of our videos in the algebraic process where we have talked about the term, expression, and equation. And when we're talking about the numbers and variables, we are talking about either the number 1 up to infinity. And the variables, you can start from A, B, C, D, depending on what you want to use. And from this unit entity being a term, is either what? 1. Variable can either be A, B, C, D, up to whatsoever you want to length you want to take it to. And this is just the basic understanding of a term. Is either a number or variable. And that is that on that. We go through the combination of like entities. The combination of like entities, we are talking about combination of like entities. That means that like simply means that they are the same. When we have 1A, 1A is the same thing as A. We have 4C, that is 4C. But the combination of like entities, that means is either you combine a number or a variable, or you bring them together. That is what we call the like entities. And under the normal sense, we can try as much as possible to use some operators on the terms. The combination of multiplication and division on numbers and variables still has to do with with a term being a term. That means by the time we combine a number and a variable, we are still getting the result of a term. This is a combined entity now. We have C, this is a term. 4 is a term. We can see here that the unit entity is either number and what? Variables. This should be all. Is either the two, numbers or variables. But the like entities, combination of like entities should be multiplication or division of numbers and variables. This is exactly what you're talking about. We have 4C. We have, let's assume we have 4 all over B, which is the same thing as 4B raised to the power minus 1. It is still under the operator multiplication. Even if you have used division as the basic operator, it can be transformed into the mathematical operator, which is multiplication, which makes it to be a term. When we have 3xyz, 3xyz is still a term because there is an operator multiplication on the numbers and the variables. And that is that about the abstract nature. Let us consider the concrete nature. The concrete nature. We have said like entities are numbers and variables under the operation multiplication and division. And the origin of the concrete nature has to do with, we have houses. Let's start with house. That's a singular. It can be represented with a particular variable. Let's assume this is S. Let's go to car. Let's assume this is Y. Let's go to home. Let's assume this is Z. House being an entity is a term. Car being an entity is a term, which is Y. And a phone, being an entity, is a term, which is Z. And when we have this as a singular part of it, when we are talking about the plural section, which we have houses, let's say 3S. Now we are talking about 3 houses now. In your particular area, by the time you have the first house, the second house, the third house, everything lies within the domain being a house. That means we have house 1, another house, another house. The total number of houses we have 3 houses. That is the concrete aspect of what we are talking about. And this leads us to the combination of like terms. We have said a term could either be a number or a variable. That variable in the concrete aspect is a representation of a particular object with a variable. Now we are talking about the combination of this has to do with the multiplication sign as a mathematical operator, subjecting the whole term to become a term. And let's go to the cars now. We have a cars. We have a 7y. That simply means that we're having car 1, another car, another car, another car, another car, another car, 1, 2, 3, 4, 5, 6, another car. That gives us 7y. But one thing is very sure here. When there is a combination of like terms under the operator positive, by the time you combine everything together, it forms a term under the operator multiplication. Now, this is a term, a single term. It has been added with another like term up to the 7th one that gave rise to 7y. Now, there is a multiplication sign here that shows the combination of those like terms to become a single term under the operator multiplication. That makes it to be 7y. When we go to the phones, that's the plural form, we talk about 2z. We are just talking about 2 phones, iPhone plus Samsung. When you have an iPhone and a Samsung, you have 2 phones with you. You put one in the left pocket, the second one in the left pocket. How many phones do you have with you? 2. It's still a phone, just numbers of the phone has only changed. So we have it to be 2z, where the z represents a phone. That means you have 2 phones with you. So in this long run, let's just look into a cow. Let's call that A. This is somehow different from what we are doing. We have cows. Let's use a cow. When we have a division now, x divided by 2. This is a cow divided by 2. That means if a cow is being divided into 2, that means it must be slaughtered and also be divided into 2. It's still a cow. It's still under the word cow because it is the beef. By the time you are dividing it into 2, it is not turned into a house. It's not turned into a phone. It's turned into a beef. That is part of a term. Because this is an animal now. We have talked about an object. So this also represents what we call as now the term. And the concrete form is represented with what you have in our environment. And the abstract form has been represented with numbers and variables. And another abstract explanation of that is abstract and concrete explanation when we have 2000 dollars. This 2000 is an entity on its own. This is a term. And the dollar is also the term. By the time we are combining the two together, you see it becomes $2,000. It is still a term. That is still the money. It is the money. It is under the range, under the domain of currency. So we'll be going into the typical example in the mathematical aspect to analyze what a term truly is. Example 1. 3yz 2 4a plus 3b 3 5c 5c squared. This is 4 abc to the power 5 ab all over dc de. We want to check if what you have written has to do with a term or another thing. You just want to confirm each of the following mathematical expressions, mathematical terms or expressions. Now, I've said expressions because we have something here that is an expression. Let's check, is this truly a term? 3yz. This is a term. How? Because we are talking about the multiplication in the term. Because we have 3 being a number, which is a term on its own. Y is a term on its own. Z is a term on its own. But it is under the multiplication operator that still anchors the 3 to be the term because they are together. And you have said earlier that under the operator multiplication, every term comes together to become a term. And in the expression here, this is an expression, this is not a term. We have 4a plus 3b. This is not a term. It's an expression you have to explain here. This is 4a. We have concluded in our video, in the previous lecture that you have been coming up with, that 4 multiplied by a is still a term under the multiplication operator because 4 is a term, a is a term, but it is being operated on a multiplication term that has to do with a singular term. That makes it to be a term. This is a term. This is another term. But there is an operator, positive here. This is positive. Because let us look into this now. This is 3. This is a term. B is also a term under the operator multiplication. This makes this to be a term. Good. But when we are talking about the combination of unlike terms, these are not like terms because it has nothing to do with the same variable. Because we are talking about 4a and 3b. When we have 4 phones, let's assume this is 4 phones, 3 pencils. Because those are 2 different entities. We are not talking about similar objects. We are talking about 2 different objects now. We are talking about the phones and the pencils. So it has 2 different terms. That makes it to be an expression. It's not a term. Because this is the combination of unlike terms. It is when we are talking about expression that this one leads to an expression. So this is not a term. And the third one here is 5c squared. We have said something. This is under the multiplication sign. Abi, we have 5 multiplied by C multiplied by C. We can see this is a term, C is a term, this is another term, because 6 times C gives us C raised to power 2. So it is under the operator multiplication that this has to do with a single and a combined term, which results it to be what? A term. We have 5 dot C dot C, that is 5C squared. This still forms a term. This is a term. This is a term. And the fourth one here, we have ABC raised to power minus 1. Because it is under the operator multiplication, it automatically gives it what we call a term. And the fifth one here is AB all over DE. This gives us AB D raised to power minus 1, E raised to power minus 1. Because it's just the same thing as AB multiplied by 1 all over what? D multiplied by 1 all over what? E. Because you have said under the operator multiplication, and also a term is always a term under the operator division. So this makes it to be a term. In the next video, we'll be looking into the analysis of expression so that it will be very clear for us before we move into the main mathematical topics. Thank you.